My name's Aparna. I'm one of the founders here at Arise, and today really lucky to have Trevor, who's one of our essays on the ground to share about what people are doing in the real world. Trevor, do you want to introduce yourself?
Well, yeah, thanks, Aparna. Hey, everyone. My name's Trevor. I'm a machine learning solutions engineer here at Arise. So I work very closely with a lot of our customers with pretty much all components of observability. So, starting with understanding use cases or the types of models that they're using, working them through data ingestion, helping set up monitors and dashboards, and, all the things that are kind of most important in terms of observability.
Awesome. Well, we have something really exciting for you all today. I guess, Trevor, let's jump into it. So we're going to start off with an overview of what are hallucinations and talk a little bit about how to detect them, why you should be measuring or evaluating to catch hallucinations. And then we'll go into a little bit more of a practical collab, kind of hands-on type of component afterward.
Cool. Aparna, did you want me to share my screen or did you want to share?
Feel free to go ahead and share so I can pull up the collab after.
Okay, let me. Okay. Cool. So kind of diving in a little bit, starting off with like, what are hallucinations? What are the type of hallucinations that you can see? Won't spend a ton of time kind of on like the broad topic of what are hallucinations, because I'm assuming a lot of people are kind of already familiar with that. But at a really high level, hallucinations are just when the model outputs text that isn't factually correct or doesn't make sense logically. So really, it's whenever the model makes up a response. And in some of these cases, in kind of your like creative use cases, it actually might be something that you'd want the model to do. However, in the cases where you kind of need that LLM to respond accurately based on your data, it's something we definitely want to be able to kind of catch and mitigate. So with that, there's kind of two different types of hallucinations. The first being hallucinations on public data, which I'm sure this is kind of what everyone's already familiar with. This is essentially when the model hallucinates based off of like what the foundation model was trained on. So for example, you ask the LLM, who is Michael Jordan? The LLM responds, Michael Jordan was the first US president, which obviously is not correct. And then the second type is hallucinations with private data. And so this is the data that's provided to the LLM in the context window. So as an example of this, let's imagine we're a company that sells cars online. We have a chat bot where users can ask questions about the cars we're selling. And the user asks a question about a specific car, context is retrieved. The model then responds with the car gets 700 miles per gallon, which obviously isn't factually correct here. And so I'm sure people can kind of see why it would be important to catch and mitigate these types of hallucinations. But I'm kind of curious to hear your thoughts on why companies should kind of care more about hallucinations on this private data aspect.
Yeah, no, I think that I like the way that it's laid out here. So there's public data, there's kind of private data. Most of what we're seeing in the real world in terms of applications is people doing retrieval on their own proprietary data, private data. And the risk here is that if the model is hallucinating, so let's say you just have an application and it's giving you what is the coverage on some product that you bought, or it's support information about, let's say, what policy. There's a little bit of a risk if it hallucinates and it says they have support for something that they don't. Well, now is it liable to give you that support because the support bot said it actually had support for some type of, you can imagine if it's some sort of like healthcare company and now they're saying they have policy support for something. And so I think there's one, which is it's more of the application use case. It's if it's on proprietary data, there's risks associated with. One, is it guaranteeing things that aren't true? Two, is it also pulling information to answer that question that might not be relevant to what the user is actually asking? So maybe they're asking about product X and it's actually pulling it about product Y, or in some cases, I think what people are really nervous about is also well, is there any customer information that it could also be retrieving from? So, something simple, like customer reviews, okay, but does it have access to things like what specific customers bought this? And is that now going into and available for these applications? And so I think there's just a little bit more risk when it comes to your proprietary data about what you want to expose. And if you're pulling in things that just aren't relevant to the question.
Yeah, I completely agree. From a lot of the customers that I've talked to as well, it's definitely a pretty big concern with them. And kind of going back to what you touched on about uh, providing wrong information about a specific product offering, it can definitely have pretty detrimental impacts further down the road. Cool. So now diving into a little bit into what kind of causes these types of hallucinations, especially kind of focusing on the private data aspect. So from talking with a lot of other companies and kind of actually seeing a lot of this ourselves too, one of the main causes of this is poor ordering of the retrieved chunks. So when you provide the LLM with a lot of information in the context window, in this case, let's imagine we're providing 4 different chunks of relevant information. If the correct answer is actually buried somewhere in the middle, it's a lot harder for the LLM to identify that relevant piece of information. And then this then kind of leads to those downstream effects of the model hallucinating based off of using a different piece of information. Aparna, anything else you want to add on this slide before we move on?
Yeah, I mean, I think the big ones are obviously, what are the right chunks? What are the right chunks that are extracted? And that's kind of where everything downstream is pulling the answer from. And so if you're pulling in, the most common thing I've seen is if the user's using words or they're referencing things that they're asking about something, but then pulling from something that's irrelevant, but the LLM or the embeddings think they're actually closer. Well, then you can retrieve information that's actually not the right answer, and then that's actually what's being used to generate. And so when you're thinking about evaluation of these, evaluating the chunks, how relevant are they to actually answering the question that the user is asking is really important. Probably more important than even post how the LLM answers on top of those chunks.
Yep. Cool. Cool. So now kind of diving into a little bit, how can we detect these? So obviously in a perfect world, we would have someone checking the output of every piece of content that the LLM generates. Obviously this isn't very scalable, and you can kind of think of it as like, we don't do this today for traditional ML models either, right? We don't have someone evaluating every single prediction that the model is making. So what can we kind of do instead to automate this a little bit more? So we'll dive into evals in the next few slides here in more depth, but sort of at a high level, we can actually use LLMs to evaluate the performance of LLMs. So again, like over the next few slides, we'll dive into a little bit more depth into like what evals are and kind of how you can use them. But this is an example prompt that you could use to detect those hallucinations on private data. So kind of without going into a lot of depth here, we're basically passing in the user query or the user question, the reference text that was retrieved, and the LLM response, and then basically asking this LLM to then evaluate whether that answer is factual or hallucinated based off of the information that's provided in the reference text.
Yeah, and in this example, there's, let's say, those 4 chunks. So each one of those could be passed in and asked. So let's say your question was, you're a merchant, you're selling products, and someone's asking you about, does your headphones support, noise cancellation? And so it would pull all of the different chunks. So product details about, let's say chunk 1's about AirPods, and chunk 2's about some headphones, and chunk 3's about something that's maybe an irrelevant type of product. And what it would do is actually ask for each one of those chunks is it relevant? If the user is asking, do these headphones, do they support against noise cancellation? And so what you're seeing here is actually a scale out that could occur. So depending on how many chunks are retrieved, that's how many different times you'll have to do this evaluation.
Cool. So kind of taking a step back and kind of just looking at evals at a high level again. So as we kind of went over at its core, right, we're using a separate evaluation LLM to evaluate the output of another LLM. So we have that input data in a query or prompt, which gets passed to an LLM to generate a response. So what we have up here, so that's again, kind of like your typical chatbot situation. User asks a question about a product. We retrieve relevant context from a vector store, for example. We pass that information with the prompt to the LLM, generates a response, which then gets shown to the user. So we actually take that input data and that query prompt over here, as well as the response. We then pass that to a separate eval LLM to generate that eval. One important distinction here is kind of the difference between task-based evals and model-based evals. Parn actually wrote a really great blog post about this, so I'm actually going to hand this one over to her and kind of let her go over the difference here.
Yeah, this one's actually very nuanced. You might all be hearing just LLM evals out. You know, it's definitely the hot thing right now. But there's actually a lot of different ways that people are using the term LLM evals. And maybe some of the biggest distinction is there's more of LLM model evals. So what that means is you have the same data set, you have the same prompt, but what you're testing is, well, is GPT-4 going to do better than GPT 3.5 instruct? Is Llama going to do better than Vicuna? So you're actually the thing that is being tested is what model should I use for this use case? And you'll see out there, like OpenAI evals actually has a pretty good library that you can use to do more model-based evals. Hugging Face, for instance, has our own OpenLLM leaderboard that has all these different metrics out there that are used to stack and rank LLM models out there. What we're going to be talking about a little bit more in this rest of what Trevor's going to be presenting is task-based evals. What that means is we're actually keeping the model consistent. It's a little bit more of what, Trevor, feel free to chime in, but like what we're seeing and with folks actually deploying LLMs is that they do make a decision. Hey, I'm going to use GPT-4, I'm going to be using GPT 3.5, whatever the LLM is, but I've made the decision on the LLM. Now what I care about is how is the whole application going to work? And really what they're testing in that scenario is the prompt template. And so in this case, you would actually have, in this image, you're seeing more of a model-based example, same prompt, different models, but actually what the task-based evals would do is different prompts, but same model. And you'd be feeding in different questions like, you might change the instruction a bit, you might change how the context looks like, how much even context, but you're actually evaluating how well is the LLM doing on the task dependent on what I have in control. And that could be the prompt, it could be the context, it could be the parameters you're sending in. And so that actually is a lot more common for actually data scientists, AI engineers who are developing these LLM applications to be using. You're maybe going to spend, maybe one iteration on the model evals to pick what your LLM you're going to use is, but the majority you're going to spend is how do I have this continuous way to benchmark my application? And on this case, Trevor's going to jump into is there's a lot of different things you can benchmark your application on.
Yeah. I also kind of like to think of it as kind of taking a page out of like the traditional ML book. You kind of start with this like experimentation phase where, you may be doing these LLM model evals where, you're trying to figure out which model is going to be best for your use case. Once you kind of have that in place, you kind of move on then to this next iteration where how do we evaluate this model on an ongoing basis in this production environment once it's actually deployed and interacting with real users. Cool. So these are these task-based evals that Aparna was talking about. These are, we have these different evals for different tasks, hallucinations being one of them. We actually pre-tested a lot of these evals with benchmark data sets for a few common eval tasks. So for example, retrieval, Q&A, hallucinations, user frustration. And so for the hallucination evals, we tested these on the QA dataset and the RAG dataset, which are both available as part of the eval library. And I guess kind of before diving a little bit deeper into the hallucination evals themselves, Aparna, was there anything else you wanted to add on kind of like this pre-tested eval set as a whole?
Well, I just dropped in the chat just the docs page to some of the pre-tested evals. So if folks want to try out the evals, feel free to do it. It's all open source, so you can see the code underneath. The key things I'd just like to highlight with this library is, one, it supports pre-tested evals, but it also supports custom templates. So these are templates that are the most common that we've probably seen across our customer base. People want to test for retrieval because they have a retrieval application. Hallucinations are important. User frustration. So we do have some that want to measure, well, if it's a chatbot, how frustrated is the user getting? There's support for toxicity. There's support for so some of our, for example, some of our users have applications that are being exposed to children. They want to make sure that the application isn't toxic in any way. And so these are all some of the most common ones that we see: Q&A, summarization, but it also supports custom. So there are some things that, if you want to go in and there's very nuanced, specific things that matter to your application, you can absolutely go in and modify it. All of these evals are benchmarked using data science rigor on the data sets are available. They're reproducible. So if you want to go in and evaluate how well the eval templates are doing, you can rerun and reproduce the results. It's really important because the benchmarking on a golden data set is kind of your way of building intuition, that it's also building confidence that, okay, on average, I can expect this eval template to work, in this case, 70-90% precision targets or 70-85% F1 targets. So you kind of have a benchmark that then when you later go use it in your real production application, those will carry over. A couple more things. It's designed to work not just in offline benchmarking, but also in production. So you want that out of whatever eval you're building. You want it to be designed for easy, quick testing. You want to run on data frames, but then you also want to be able to run it on your actual Python pipelines, designed for throughput, so that when you're doing hundreds and thousands of these type of predictions, your evals are running on there. So check it out. I think there's a lot of nuance in how you want an evals library to look, but today we'll just focus specifically on hallucinations.
Yeah. Oops. Cool. So yeah, this is the Prom template for that hallucinations eval. Just for the sake of time, I'm not going to bore everyone by reading through this entire thing, but kind of at a high level here, the Prom template says, you're presented with a query, a reference text, and a response. It describes what a hallucination is. And then we have a spot at the end where we're actually providing that input. So providing that user query, providing that reference text, as well as the LLM response. And then kind of like this binary decision here, asking the LLM whether or not the answer above was factual or hallucinated based off of that reference text that was provided and the user question. Cool. So for these like pre-tested evals, we actually tested this hallucination eval with GPT 3.5 as well as GPT 4. And so here you can kind of see the confusion matrices for both. And the reason why we took this approach rather than kind of just looking at a metric like accuracy, for example, is because accuracy might not kind of give you that full picture of how this or what this benchmark should be. And so kind of, again, taking a page out of the traditional ML book here, we have unbalanced classes. Accuracy is not really going to tell you much, right? And you can imagine in a chatbot scenario, we probably want our model to not be hallucinating that much at all. And we want a lot of our responses to be factual. And so that's why it's important to kind of look at metrics like precision and recall and F1 score to help kind of give you a better picture of how this model is actually performing, rather than just looking at kind of like a metric like accuracy, for example. And so here on the left-hand side, we have the confusion matrix for GPT-4. And then on the right, we have the confusion matrix for GPT 3.5. And in this case, the model, the GPT-4 model, does perform a little bit better on this hallucination evaluation task, given that prompt template and kind of that golden data set that we were using. Aparna, anything else to add here?
No, I think this is great.
Cool. Is there something in the chat? This is for days. Okay. Yes, I believe both the first two sessions are recorded and saved somewhere. Cool. So kind of diving into a little bit on, okay, we detected hallucinations are happening. What do we then do? How do we fix these? So there's kind of three main recommended fixes that we've seen kind of work in these types of scenarios. So the first is improving retrieval or ranking of relevant documents given a user query. And without kind of diving like super into the weeds here, Aparna, I'm kind of curious to hear from you. Like, what are some of the most common methods of like document retrieval or ranking that you've seen across other companies?
Yeah. So first I'd say there's a lot of different ways that people out there are doing it. There's some that are definitely using, the ones that are pre-connected, for instance, to Llama Index, LangChain, and using that to orchestrate the connection to the vector stores. There's also people that I've seen who have built this all without any orchestration frameworks like that. They typically do benchmark. And I think this is really important. They do benchmark things like how many chunks are relevant? How do we chunk our data? And so some of that, for example, is if you're chunking by characters or token, you could chunk by cohesiveness of what a chunk actually means. We have some people during retrieval who actually not only pull the chunk that was identified as the closest, but then also pull like the close by relevance, chunk. So for example, if you're on a document or a page that's asking about a specific product, they might pull some of the other relevant products nearby it because they might be similar. And so the retrieval itself, we have some people that will do a retrieval, but then they'll also re-rank the documents. So they'll do an intermediary around how close was the actual question to each one of these specific chunks, and then do a separate re-ranking. The documents, so there's just a lot of different ways to optimize either the chunk size, how many chunks is something I've also seen people iterating on. Too many, what ends up happening is that you're just giving a lot of information to the LLM, and sometimes the chunks start to compete with each other or start to disagree with each other. And so now you have the LLM have to be the one that's making a decision. And so there's actually a really good script that I'll link in the chat, but it's a really good way to, if you are building your own retrieval system, looks at a couple different things like the K value, how many chunks, what's the size of the chunks, and then the metrics like MRR, precision at K, and DCG. So it has a number of these different metrics that I think are helpful for teams to start benchmarking this. And then I'll go through some of this during the demo as well.
And Aparna, we actually have there's a question in the chat. What about context windows? So obviously it kind of depends on the use case, but any general thoughts on long context windows?
Yeah, really good question, Mert. So absolutely true. We do need to fit the context that's retrieved into the context windows. So one thing that this one relates to is what's the size of the K? You could, if it wasn't for any context windows, you could have argued, well, just pull as much information as possible, retrieve as many documents, and then send it all. Like the more information you give it, the better answer it's going to come back with. But I actually think this one's been, through various experiments that we've run, Llama Index has run, a number of actually even vector stores have been publishing out. More context that's provided doesn't necessarily mean a better answer. And so I think it's actually really important to benchmark for your use case. What is the right K? People call this the K value, like K number of chunks that you're retrieving. What's the right K to actually retrieve that improves your metrics? And then I saw one more question from Harpreet, I think. Yeah. How important would metadata be to fix hallucinations? That's a really good question too. So we are seeing this, by the way, rise in popularity right now, which is adding a structured data filter. So a lot of the vector stores actually now support this, where you can go in, Pinecone has this, for instance, where you can go in and you could do restrict what it helps is it just restricts, right, the products, the surface area that you now have to search over. So for example, if it's a product specific types of questions, they might restrict over, well, what are products that are available for this specific region that the user is asking a question to, or is available to this user. And so you can actually go in and restrict on the surface area. And then what it does is it just gives you more meaningful content to then go back and feed to the LLM. Cool. I'll hand it back to you, Trevor, before I go into the demo.
Cool. So two other quick ones, and I think we kind of talked about the second one a little bit already, but improving the chunking strategy and document quality. So again, you can kind of imagine garbage in equals garbage out, right? If you have a lot of really low quality documents that you provide to the LLM, you're probably going to get a pretty low quality response. And then the last one is prompt engineering. I'm not going to spend too much time on this one because I'm sure a lot of people are already familiar with what this is, but basically being able to, continue to iterate on your prompts and kind of, find that sweet spot between or find that sweet spot after running some of these evaluations, seeing how your model is doing in production, kind of figuring out what you need to iterate on in that front. Cool. And then the last slide I think we have is kind of just research on the subject and where the industry is kind of heading. There's a lot of research out there on hallucinations today. A lot of it in the past is kind of focused on hallucinations on public data. So again, this is kind of like the hallucinations for those foundation models, using that training data as sort of like what we're identifying as like public data in this sense. We are starting to see a lot more research though on hallucinations with private data now too. And one kind of interesting industry direction is this emergence of guardrails. And so this was actually back in April of this year, but NVIDIA came out with their NeMo guardrails package. They actually have a guardrail specifically for hallucinations. Definitely seeing some companies now trying to test this out a little bit. Not really seeing a whole lot of them make it to production yet, but I don't know, Parna, have you seen anything different in terms of kind of if companies are out there today using guardrails in this production setting?
I mean, I think it's a really exciting new area. I haven't been seeing it in production yet. And my reasoning, my hypothesis on this could just be if it's another call you have to make before you can block an answer to a production application, you have to be really, you either have to have an application that is just prone to making a lot of mistakes, that it's definitely worth the investment to putting the guardrail, or if it's too risky to roll out without. But what I've been seeing more people do is offline evaluate. So definitely growing. I think if we could be faster, if they could parallel, not make it blocking, it's definitely an interesting area.
Yeah, I agree. And it looks like we have another question in the chat. Is there a way to determine the accuracy of the self-evaluation of the LLMs to their own hallucinations and relevance to retrieved docs? Is that where the benchmarks come in?
Yeah, I think I actually might go into that when I hop over to the demo section, but really, really good question, Christos. I feel like part of the question you're asking is almost like how do I trust my own evals? And how do I know that it's actually not prone to its own issues. And so I think that's a really good question. We're gonna jump into that in a second.
Cool. I think that actually might be the last of my slides. So Aparna, I'll hand it over to you.
Awesome. Okay, let me go ahead and pull up what I'm going to go through. Okay. Can you all see my screen?
Yeah.
Okay, awesome. I have a really wide view right now. So if you can't see the screen or anything, please do let me know. Okay. So first thing what I'm going to talk about might actually be helpful before I jump even into the hallucination evals, because I think Christos's question kind of gets at this, which is, well, how do I trust my own evals?
Aparna, can you zoom in a little? Sorry.
Yes. Can you guys see this now?
Yeah.
Okay, awesome. What I might do is just spend a little bit of time talking about how the process of building your own evals goes. And I think in talking about that, we're all able to first build okay, this is how it's built, and then we can jump into how to actually, we'll go into the specific COLAG example about how to run an hallucination eval. And all of this is available in the docs, so we'll post it in the chat. So the first thing is choosing the metric. So today with hallucination, it's actually one of our pre-tested evals, but let's say you wanted to build your own eval, you typically need to just understand what's the question that you're trying to ask. In this case, let's say we were just trying to rebuild the hallucinations one. The question we'd ask is the answer hallucinating? Is the answer pulling information off of this specific context? So you first need to come up with some sort of metric. It can be a binary answer. It can be, it can have multiple outputs. Like I've seen some people ask things like it's partially relevant, it's fully relevant, it's not relevant at all. But you first just want to decide, well, what's the question that you're going to ask? This one's kind of the most important part of this, which is building a golden data set. So if you're used to traditional ML, it's almost like the parallel you should think about it is almost like a training data set, except your training data set for your eval. And what it typically looks like, so let's just say we're doing the hallucination one. Do you support international calling? Maybe you're some sort of support application for something like a Zoom. Well, you're asking, do you support international calling? There's some context that's retrieved. So this is your private data. These are documents. And then in this case over here, instead of the question being, is the context relevant? We might ask, hey, is the answer that's generated based off of this context? So is the information that was pulled only information that was pulled from this document, or was there any other new information that it made up? And so this over here is really the metric that we were talking in step one. And typically what you want is some sort of, data set with these labels pre-provided. These can be laborious to build. You're going to probably need some sort of human feedback. But building this data set, you could use things like some public common data sets, but for your use case, what we've typically seen people do is actually build this themselves to get it to be a really good eval. So once you actually build the golden data set, this is a little bit lighter of a step, but you need to decide which LLM you're using for the evaluation. We've seen people who actually do use different evals. So they might use, let's say, GPT-3 to actually answer the question for the application, but then they might be using a different LLM to actually do the eval itself. It really is just dependent on your use case. We've seen people use the same, we've seen people use the different ones, but really the point here is just that these are two separate LLM calls. One is for actually the response back to the user. One is actually the response. One is actually the evaluation score for this response. And so what you're going to do is you're going to then build your eval template. This is actually the one that is really the most core component. And you're going to probably iterate on this over and over again. The things to just be explicit about is what's the input, what are you actually asking, and then what are the possible output formats. So in the hallucination one that Trevor was going through, I'll just go into the hallucination collab over here. But let me read out this one so you guys can see it. So this is the hallucination template. It says in this task, you'll be presented with a query, a reference text, and an answer. The answer is generated to the question based on the reference text. So here's the three components: the query, the reference text, and the answer. The question may contain false information. You must use the reference text to determine if the answer to the question contains false information, if the answer is a hallucination of facts. So really, in this specific one, you have to be really clear about what's the input question, this is from the user, this was the answer that was given to the user, and then this was the reference text. So the one I'm kind of walking you through in the docs right now, this is a little bit different. It's a little bit more of a relevance type of eval, not a hallucination eval. And so this one, I don't actually need for the relevance eval, I actually don't need the response that you saw up here. But for the hallucination one, you do need the actual response for this eval. So again, depending on what your metric is, you'll just need different components to answer that question. So your objective is to determine whether it's a hallucination. A hallucination in this context refers to an answer that is not based on the reference text or assumes information that is not available in the reference text. So it's clearly stating, here's the inputs, here's the instruction, what you're going to be doing. And then here it starts to define what should the output look like. Your response should be a single word, either factual or hallucinated, and it should not include any other text or characters. Hallucinated indicates that the answer provided factually inaccurate information based on the reference text. Factual indicates that it's correct, relevant to the reference text, and does not contain made up information. So what you're doing again is, what's the input? What are you asking? What's the objective? And then clearly state what the possible output formats are. And depending on your metric, again, the one I'm going through in the docs is more of a retrieval one specifically. So in that one, I really only care about, is the context that was retrieved actually relevant to the question that the user is asking? You just need to determine what parts to feed into the eval template, and then what should the output look like. Okay, so a lot of questions.
Yeah, Mert had two pretty good questions in the
Awesome.
chat. So excuse me. I think the first one, are we generating evals data set with GPT-4 or manually by humans?
Good question. So some of these are actually by, I think most of the ones, it depends on the metric, I'd say, Mert. So some of them are actually using public data sets. So if I just go over here, for instance, the retrieval eval that you're seeing is tested on MS Marco, there's WikiQA. So some of these are really public common data sets. Some of them are on ones that are a combination of, fully human, or some that are modified with human and some additional GPT-4 modifications. I think most of them, though, if I'm honest, it's typically good to start with just a human one or a public data set. Reason being is I think if you really can't generate, if your application's not deployed and it's not live yet, you might be forced to start with, okay, well, I'm trying to simulate some data sets or build a synthetic data set. And so in that case, you might start with the GPT-4. If you have an application that's already live in production, you probably have stuff that's human generated. And you can you can ask for labels on that human data set. And so I'd say there's typically a preference for it to be human generated. So you just want it to be the most closest to what's actually going to happen in the real world. But we do see a lot of people who, just given the fact their application is not deployed yet, they're going to have to build those synthetic data sets to even have a starting base. But great question. Okay, let me keep going here. I actually see one more question from Harpreet. Curious if you've seen anything like golden examples for retrieving few shot examples that are most related to the user query. Feel free to ignore. I think I need to understand the question just a little bit more. So if you can add anything to the question, that'd be super helpful, Harpreet. Okay, I'll keep going here. So we just went through building the golden data set. We went through deciding which eval. Okay, we talked about building the actual eval template. Again, this is for, you can use the pre-tested evals, but if you're going to, I recommend everyone to just build their own, just to build some kind of intuition. But basically, once you build your eval template, now you want to test the efficacy of that template. So you want to run your eval on your golden data set. The reason to run it on your golden data set is because you already have labels on your golden data set. So you can actually run it on your golden data set, and you can compare side by side, what should the actual answer have been and what was the response that was generated by the LLM. And then you can actually then run all sorts of different metrics to say, well, how accurate was my LLM generated ground truth versus the true ground truth. I highly recommend not just using accuracy, and the blog post, if you guys read it, has really good explanations of, if you look at accuracy, you're kind of looking at just like overall correctness, but what you really care about is, are you more precise? You want to understand simple data science rigor around using precision and recall. Is it get it more right when the answer is no, but it should, does it commonly mistake for no hallucination when it is a hallucinate? Is it too strict? Is it too loose? So there's kind of good ways of actually understanding the edges of your eval. And going back to like Christos's original question, this should help you build your confidence in your eval template, because you run it, you've tested it on your ground truth, and you start to build some intuition around, okay, it's doing pretty good on precision, maybe it needs improvement on recall. You can actually go back and then tweak the template. So in this case, this is a hallucination template. You can go back, maybe it messes up. Specifically, it says that something hallucinates if it uses slightly different words or synonyms instead of the actual information that was in the reference text. Well, then you can specifically put that in the template. Say, hey, it's okay if you're using slightly different words, as long as the information is equivalent to what's in the reference text. So you can go back and modify this. If you want to be more strict, hey, if it introduces any new concepts that's not at all in the reference text, I want you to mark that as a hallucination. But you can go back, you can iterate on it, you can build your intuition, and then you can then use that eval to go back and run through on your actual application, which is great, because in the real world, you're not going to have this type of ground truth like I'm showing you here. You're not going to have this on all of your production data. And so now that you've built your intuition, you can then go back and run it on production data. Okay, Christo says, one more question. Are there any strategies out there such as adding a scalar weight of importance to human examples? Or is that case by case engineering art? Yeah, I mean, these are all really great questions, Christos, I gotta say. So yes, I do think similar to what we've seen out there in typical data science world, you can have some samples that are more important or more weighted, and you can generate. This all comes back down to the different benchmark metrics that you want to use. So depending on the right benchmark metrics, if you want to weight some examples more than other examples, totally up to you. I'd say it's totally up to your golden data set. It's totally up to your use case. I think the most important thing is just knowing the right benchmarks, metrics that you want to use. I'd say for most people, just accuracy doesn't quite cut it. But using things like precision recall or weighted precision recall, all of those are good ways. So this is how you build an eval. You go build your golden data set, decide what the eval template should be, run the benchmark, and you'll notice I'll go to the hallucination one specifically now. If you want to try any of our pre-tested evals, what you can see is you'll actually see the template, but then you'll actually also see the benchmarked results. And these are the benchmarks off of the data set that I'd shown in that previous page. So it could be on MS Marco or WikiQA, but you'll see here that we actually ran these using GPT-4, and then we also ran these using GPT 3.5. And they're slightly different. For example, here, the precision when it was hallucinated, GPT-4 did slightly better, 92%, versus GPT 3.5 got 89% precision. So, probably not a surprise to anyone, but GPT-4 did slightly better. And so this is also a good way when you're doing your benchmarking of knowing, well, how accurate is accurate enough for you? Is getting it, because you also need to consider cost in this as well. So, is it okay that you use GPT 3.5? Is the margin of error not that crazy that you're okay with this on your production data? Anything else you'd add to this, Trevor?
No, I think yeah, that was a very comprehensive overview.
Cool. Cool. I think the big thing probably just recommend is definitely most people, what they'll probably start with is running some sort of pre-tested evals. These are all already benchmarked. They're all already supported on a number of major model types. So for instance, here, they all work with like GPT-4, Prom, AWS Bedrock. But I think that as your application gets more nuanced and you need, if you notice there's a specific part where you're consistently seeing errors and you want to start generating evals for that, that would be a great time to actually build your own eval, build your own data sets to do this. And then you can actually contribute back if you'd like to the Phoenix library. So now going specifically to the hallucination collab, this is more of once you actually built your eval template, this notebook actually shows you how to run it. So you'll import Arise Phoenix. You'll pull down the benchmark data set here. So in this case, we're just showing you how to run it on our benchmark data set. Typically, though, this one might actually be a good one to show you all. What you want for your evals, and this is kind of what Trevor was highlighting too, is that you want your evals to be able to run in different environments. Oh, sorry about that. Let me go back. Oops. So you want your eval to be able to run in different environments. What that means is you want to be able to use it when you're actually doing the benchmarking. So in this case, when we were actually building the eval, you want to use it then. You want to be able to use it when you're maybe developing, now that you have an eval metric, you actually want to evaluate your application that you're building. This might be before it's actually even launched. So we have some people who are building, let's say, chatbots on their proprietary data. You might want to actually build your eval and test it in a notebook on your application. And then lastly, you'd ideally like to run this eval once the application is deployed in production. And so this same eval can be run in all three of these different environments. And right now for this example over here, I'm just going to show you how it runs on the benchmark data set. So we pull down the benchmark data set. I've decided I'm running it on the hallucinations eval data set. This is an example of what that data set looks like. So kind of like the image, it has the context, the reference here. Let's keep going. It has the query, which is over here. And then it has the response. And then here, his hallucination, this is the ground truth that we were showing. So these are the 4 columns that really matter. We've generated our template, so I can just print that template out. You will need your OpenAI key or whatever LLM that you want to use for it is. So in this case, I'm using GPT-4. So I've gone ahead and I'm now just running the eval itself. So I'm going ahead and I'm just running it. And then once I run it, I just display the results of the actual confusion matrix. And so this is kind of the way that you all can test the hallucination template on your own data sets as well. I think that is it for today. At least that's all in the example that we had for today. If you have any questions, I know this is a super exciting and also growing space. Feel free to drop questions to us in the Slack group. Check out the docs, check out the templates. Feel free to try it yourself. But all and any feedback is welcome on this. Anything else you want to add to close us out, Trevor?
No. Yeah, thanks so much everyone for joining. I was had a great time going through all the eval stuff. So yeah, really appreciate everyone joining.
Awesome. Thanks everyone for joining. See y'all at the next one.